In this video, we're going to look at something called conditional probability. So this is our next topic, and we're specifically going to look at how it's related to medical testing, which is an important application, something that we should all know more about. So what conditional probability is conditional probability is the probability that B is true given that we already know A is true. Okay, so it's the probability of one thing if we know that something else has already happened. And we already saw one example of conditional probability, and we'll go over another example like this in a moment, where we were drawing marbles out of a bag. And we said, the probability that the first marble was red was 5 out of 10, but then the probability the second marble was only being red was only 4 out of 9 because there were only 4 red marbles left out of 9 total. So that's one example. Another example is something like a conditional probability example using this table, which I wanted to leave up on the board and talk about first, would be something like, what is the probability? So in the last video, we said the probability that an American is a Republican is 416 out of 1,000, 41.6%. But what is the probability that a white American is Republican? Okay, so this is a conditional probability because we're looking at what's the probability that somebody is a Republican given that we already know that they're white. It's not going to be 41.6% again. So what we're going to do to compute conditional probability is it's going to be the probability of A and B divided by the probability of B. Probability of A. Make sure I've got this correct. So if we want to know the probability that B is true, given we already know that the probability that given that we already know A is true. So in this example, we want to know the probability that somebody is Republican, given that we already know that they're white. We're going to look at the probability of both being true divided by the probability of the one that we already know being true. Okay? So in this particular case, probability of both being true, there are 353 people in the sample of 1,000 that are white and Republican. So we've got 353 who are white and Republican, and we're going to divide that by the total number of whites. We're looking for the probability that they're Republican given that we already know that they're white, so we divide by the number of whites total. So 353 divided by 653 is going to give us is 0.54, 54%. Okay, so substantially different than the 41.6%. Similarly, if we wanted to know what's the probability that somebody who is black is, or what's the probability that somebody who is a Democrat is black, we would take 133, the number of people who are Democrats and black, divided by the total number of Democrats, 509, so 133 over 509. Okay? So let me just go over kind of this difference. So the probability that a Democrat is black, we already know that they're a Democrat, we just want to know what the probability is that they're black. That would be 133 over 509. Whereas if we were looking for the probability that a black person is a Democrat, Then we would take the number of people who are black and Democrats, 133, divided by the total number of black people, 152. Okay? So what we divide by depends on what we already know. So in this case, probability that a Democrat is black, we already know that they're a Democrat. We want to know the probability that they're black, so 133 out of the total number of Democrats. If we want to know the probability that a black person is a Democrat, 133 out of 152. The number of black Democrats divided by the total number of black people. Okay? So that's conditional probability. Another example of how it works, again, just to kind of go over kind of another kind of viewpoint of conditional probability from the theoretical perspective. Say you've got a bag of marbles with 3 green, 4 red, and 3 blue. Okay? If the first marble you draw is green, what is the probability the second marble is green? So you draw 2 marbles. If the first marble you draw is green, what is the probability the second marble is green? Well, you need to think about, if you've already drawn out a green marble, how many are left that are green? Only 2 are left that are green. Out of how many are left total? There were 10 originally. You already pulled 1 out. So there's only 9 left. So the probability that the second marble is green is 2 out of 9 if the first marble was green. If the first marble was red, then the probability the second marble is green is going to be 3 out of 9. There are still 3 marbles left that are green out of 9 total marbles left. Okay? So these are all examples of conditional probability. Something has already happened. What's the probability now that it's changed? Okay? So the main way that we're going to use conditional probability is in medical testing. And I think I'm going to put that in the next video. So our next video, we'll talk about some terms from medical testing and conditional probability in medical testing.